Hi guys. For this video we're going to be taking a look at section 1 of chapter 8, and we're actually going to be breaking that section down into two videos. So this will be part 1, where we are going to we're going to learn about a new term. It's right up here. It's called the geometric mean between two numbers. So we're going to learn about that, and we're going to review something that you probably learned in Algebra 1, which is how to simplify a radical. And like I said, you probably learned it in Algebra 1, but you might have forgotten some of that. So we're going to review that because we'll be using that skill a lot in Chapter 8. So let's jump right in. First off, we're looking at a definition. This is going to be the definition of geometric mean. And it says if a, b, and x are all positive numbers and a over x equals x over b, then x is called the geometric mean between A and B. So you've probably heard the term mean before, which is synonymous with average, which is where you add a bunch of numbers up and then divide by how many numbers there are. This is a different type of mean. This is called the geometric mean. The one I was just describing, the one that you probably think of as average, is called the arithmetic mean. This is going to be called the geometric mean. And so, a couple examples down here where we are just going to use what we just learned about the geometric mean, and we're going to apply that. We're going to find the geometric mean between a pair of numbers. So the first pair is 3 and 12. And so to find the geometric mean, what we're going to do is we're going to set up a proportion, kind of like what we see up here in the definition, where the numbers 3 and 12 are going to be our A and B, and then we're going to try and find what this x would be. So we're going to put the 3 up on top of the first fraction. We're going to put the 12 in the denominator of the second fraction. And we're going to put x's in these other two spots. And then what you'll notice happens when we cross multiply is we do the 3 times the 12, and then we do the x times the x. And we know that when we multiply x times x, we get x squared. So what this means is that 36 is x squared. Now what we have to do is we have to figure out, well, if 36 is x squared, then what is x going to be? Now we don't divide this by 2 because x squared is not the same as 2x. What we do is we take the square root of both sides, because that's how you undo, if you will, squaring x. You would have to square root it, and if you square root this side, you're going to have to square root this side as well. So x will be the square root of 36. Now we get a little bit lucky here because 36 is actually a perfect square. Some numbers are perfect squares, others are not. This one is a perfect square, and what that means is the square root of this number is an integer, and in fact it is 6. Technically it's positive or negative 6, but up here in the definition we see that we are looking at x being a positive number, so we only care about the positive square root of 36, which is 6. So 6 is our geometric mean between 3 and 12. And we can check it. We can notice that if we go 3 over 6 and 6 over 12, those two fractions do equal each other because they both reduce to 1/2. So 6 is our geometric mean between 3 and 12. Now in this other example, we have two other numbers, and it's not going to come out quite as nice as what we had right here. And I'll show you what I mean. We're going to set up our proportion, where we're going to put 7 in the numerator of the first fraction, we're going to put 10 in the denominator of the second fraction, and we're going to put x's right there and there. Now when we cross multiply this one, we know we're going to multiply the x times the x and get an x squared, and we're going to do 7 times 10, which we'll go ahead and write out as 70. So now we have x squared is equal to 70. So to get x by itself, we need to do the square root of both sides. We need to square root that side and square root that side. So when we square root x squared, we get x. And this over here, well, that's the square root of 70. And 70 is not a perfect square. Now we could type square root 70 in our calculator and we'll get 8 point something, 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 something. It's going to be some really big, long decimal number. It'll actually be what's called an irrational number because it won't ever repeat or terminate. Because most numbers, when you take the square root of them, you get one of those irrational numbers. It never repeats, it never terminates, it's a big, ugly, long decimal. We could round that, but we don't want to do that because it's actually rounding is choosing a it's purposely choosing an inaccurate answer is really what rounding gets you. Because when you round, you're not giving the exact number, you're giving something that's really close to what the exact number was, but you rounded it. You made it slightly inaccurate. So in this case, we're just going to leave our answer as the square root of 70. That is going to be the geometric mean between our two numbers 7 and 10. Now if we check this one, it doesn't look quite as nice as the example A over there did when we checked it. But you'll notice what happens is I don't want to reduce this necessarily because the square root here it's just kind of weird to reduce. We could do it technically, and we're going to actually learn how to maybe get rid of this square root that's on the bottom of this fraction and see what it would look like if we try to reduce it. But what we could do is also we could just cross multiply it. And when we cross multiply, we notice that we get 7 times 10, which is 70, and square root of 70 times square root of 70, which means you're squaring a square root. And a short explanation of what happens there is when you square a square root, if you have the same number underneath the square root, then you kind of get rid of the square root, and so we would just end up with 70. And so the square root of 70 is our geometric mean between 7 and 10. Now, like I said, we need to know how to work a little bit with these radicals because we're going to see them a lot when we work with geometric means. We often will work with radicals when we are finding geometric means, and also with some of the other things that we're going to do here in Chapter 8, we'll have a lot of radicals going on. So we need to learn something about radicals, or relearn it probably, because like I said, you should have heard it a little bit in Algebra 1. And that is that the radicals should always be written in simplest form. And what does that mean? Well, to write a radical in simplest form means that three things are going to happen, or three things I guess technically are not going to happen. First of all, there will be no perfect square factors other than 1 underneath the radical sign. So factors are are numbers that a larger number can be divided by. And so what we're looking for here is when we have a radical, we want to make sure there's no numbers that are perfect squares that we can divide that number underneath the radical by. And so it might help to either, if you don't already know them, to kind of memorize what your perfect squares are. So of course 1 squared is 1, and that one's we don't usually have to worry about because like it says, 1 is always a factor of any number, so you're never going to be able to get rid of that factor underneath the radical. It will always be there as a factor of whatever you have underneath that radical. But the other ones you're going to want to know, of course, 2 squared is 4, and 3 squared is 9, and 4 squared is 16, and 5 squared is 25, and 6 squared is 36, and 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and we'll go up to 12. 12 squared is 144. So you need to make sure that whatever number you have underneath the radical cannot be divided by any of these numbers right here, your perfect squares. And I'll show you in a second a technique for how you can make sure that that's not happening, but that's one of the things you have to look out for. No perfect squares as factors underneath the radical sign. The second thing is you need to make sure that you have no fractions under the radical sign. So the square root of 1/4, that's a no-no. We can actually simplify that. Or the square root of 3/8. We don't want anything looking like that as a final answer. And I'll show you down here. You can see in example B. We're going to take a look at how we can change this to make sure we don't have a fraction underneath the radical sign. And last thing we want to make sure we avoid is any fraction that we do have in our answer cannot have a radical in its denominator, or the bottom term on the fraction. And I'll show you how you get rid of a fraction. It's called rationalizing the denominator. I'll write that down. It's called rationalizing the denominator. And that is something that you're going to need to know how to do. And luckily we'll see that in an example here in just a second. So let's look at example A here, and let's simplify this. It says the square root of 25. Now, there are a couple ways you can simplify this. First of all, you could notice that 75 has one of these numbers as a factor. There is one of these numbers over here that you can divide 75 by. And most of you can probably see that it's going to be 25 here. So here's one way we can do this simplification right here. What we'll do is we'll take the 75 and we'll rewrite it as 25 times 3. And then one of the things you should have learned about in Algebra 1 is that when you have a product underneath a radical, you can take each factor in that product and put it under its own radical. So this can turn into square root of 25 times square root of 3. Now the square root of 25, since it is a perfect square, will turn into plain old 5. So now you have 5 times the square root of 3, which we usually don't write with that multiplication sign in the middle. We usually write this as 5 root 3. And so this is the simplified version of square root 75. Now the nice thing about doing these square roots is that you can always check these on your calculator. If you type in square root 75 on your calculator, what you should get is, let me do it here real quick on my calculator, you get about 8.66. And if I type in 5 square root 3, I should get the exact same thing. If I get two different numbers on my calculator when I type in square root 75 and 5 times the square root 3, then that means I did something wrong in my simplification. It's a really easy way to check and make sure that you simplified correctly. Now I told you there was a couple ways of simplifying square root 75. So let me show you another way that you could do this. And this might have been the way that you learned in Algebra 1. If I take 75 and I break it down into its, what we would call its prime factorization. In other words, I think, okay, 75 is 25 times 3, and 25 is 5 times 5. So this is the prime factorization of 75. It's all the numbers at the end of this little tree here. 5 times 5 times 3. I'm going to write that underneath my square root sign right here. 5 times 5 times 3. Now when I have that broken down into its prime factorization, what I'm going to look for is I'm going to look for doubles. I'm going to look for a number that is repeated. Or maybe there's going to be more than one. Sometimes there's going to be more than one number that will be repeated in the prime factorization. But I notice right here that I have 2 5s in my prime factorization. So what happens is I circle, just as a visual reminder, I like to circle those 2 5s. And then I tell myself those 2 5s are going to come outside the radical as a single 5. Whatever is left underneath the radical, maybe it's one number, maybe sometimes there'll be more than one number. Whatever is left underneath the radical sign is going to get multiplied together, and it's going to stay underneath the radical sign. So in this case, that's just going to be a 3. So you can see my prime factorization was 5, 5, 3. I circled the 2 5s. It came outside as a single 5, and the 3 stayed underneath the radical sign there. Again, 5 root 3 is my simplified form of square root 75. And so you see, I got the same answer either way. It's just a personal preference which you like to do. Are you going to want to try and find which perfect square factors you might be able to divide by, or are you going to want to do the prime factorization and look for pairs? It's up to you. Now when we come over here to example B, we have the thing that's wrong with example B, the thing that needs simplifying is we have a fraction underneath the radical sign. So let me show you how we're going to deal with this. What we're going to do first is we're going to take that radical sign and we're going to put it over the numerator and the denominator. Now this, however, does present another problem because now we have a fraction with a radical in its denominator. We don't have a fraction underneath the radical anymore, but we do have a fraction with a radical in its denominator. And so this is where that whole rationalizing the denominator comes in. And what we're going to do is we're going to do a little mathematical trick. We're going to multiply this by 1. And we know that when you multiply something by 1, you don't actually change its value. So it's kind of like it's a move that you can do without worrying that you're doing something wrong. You can always multiply anything times 1. But we're going to multiply it by a special version of 1. We're going to multiply it by the square root of 5 over the square root of 5. Now we know this is a 1 because when you have the same number on the top and bottom of a fraction, you know that it's really just a 1. But what this does is, you can see on the bottom what's going to happen is, since I'm multiplying square root 5 times square root 5, In other words, I am taking the square root of 5 and squaring it. So I'm going to write over here. I'm going to write it like that. Square root of 5, and I'm squaring it. What's going to end up happening is that squared is going to kind of nullify or get rid of the square root that's over the 5. And so I'm going to be left with just 5. And so you can see I took care of the fact that I had a square root on the bottom of my fraction. Now I don't have it anymore because I multiplied that square root of 5 times itself. But I still have to deal with the top. And so I had the square root of 2 on the top, and I'm multiplying it times the square root of 5. And so now we know that that means it's going to be the square root of 2 times 5. That's one of the properties of radicals that you should have learned in Algebra 1, is that when you multiply two radicals together, you can just take the numbers underneath the radicals and stick them under one larger radical and then multiply those numbers together. So the square root of 2 times 5 is the square root of 10. And so the square root of 10 over 5 is my simplified version of the square root of 2 over 5. Now again, I can grab my calculator and I can kind of check this and make sure that I did it correctly. What I want to do in this case is I'm probably going to do 2 divided by 5 to get 0.4. So this is the square root of 0.4. And then I'll do the square root of 0.4 on my calculator, and it gives me about 0.632. Now over here I have the square root of 10 divided by 5. So I'll do the square root of 10 divided by 5. And what I should get is I should get the same value. Square root of 10 divided by 5, and again I get about 0.632. So you can see this is the same number as the square root of 2 over 5. It's just in proper form. It's in simplest form. Now some of you are going to wonder, can I reduce the 10 here and the 5 here? Can I divide both of these by 5? And the answer is no, because this square root of 10 is not the same as 10. This square root of 10 is actually going to be like 3 point something, like 3.1 or 3.2 or something like that. And so that's not an actual 10 right there that I can divide by 5 like I can with the 5 that's down here. So this is, if there was a 10 outside the radical, I could do that. I could divide this 10 that's outside the radical by 5 and this by 5, but with the 10 underneath the radical, I can't do that. So square root of 10 over 5, that is my simplified version of the square root of 2 over 5. Now lastly, we have this expression, which is 2 times the square root of 48. And so I want to check and see, can I simplify, specifically, can I simplify the square root of 48 part here? Again, I could look for a perfect square factor that I can divide this by, or I can take that 48 and I can start thinking, what is the prime factorization of 48? Now when I think of 48, I think of 4 times 12. And then the 4 is 2 times 2, and the 12 is 2 times 6. And the 6 is 2 times 3. So the square root of 48 is going to be 2 times 2 times 2 times 2 times 3. And so now what I do, since I've got my 48 broken down into all its prime factors, is I look for the pairs. There's a pair of 2's that can come out. And then I have another pair of 2's right here that can also come out. Now what happens is each one of these pairs of 2's comes out as a single 2. So now I have this pair of 2's comes out as a 2, this pair of 2's comes out as a 2, and I still have this 2 right here that was always outside my radical, so it's outside there too. And what I have left underneath there is the 3. So 2 times 2 times 2 is 8, and then I have times the square root of 3. And again, I would recommend that you type the 2 root 48 in your calculator. Check and see what that comes out to as a big ugly decimal. Type the 8 root 3 in your calculator. Make sure it comes out to the same big ugly decimal as what you end up with up here. And it should, and I think we did this correctly, but you always want to check those if you have time. All right. So on the second video, we'll start down here when looking at theorem 8-1. We'll learn what that has to do with geometric means. It involves this idea of a geometric mean when we start getting into theorem 8-1 and its corollaries. But that's all for now, and I hope to see you back for the next video.